Class 10, Chapter 1, Real Numbers, Exercise 1.3, Question number 1. Prove that root 5 is irrational. Now, to prove that root 5 is irrational, first we will assume that root 5 is rational. Then, we will contradict this assumption to prove that root 5 is an irrational number. A rational number can be represented as a by b, where b is not equal to 0 and a and b are co-prime numbers. Since root 5 is a rational number according to our assumption, root 5 will be equal to a by b, where b is not equal to 0 and a and b are co-prime numbers. This can be further written as a equals b root 5. Squaring both sides of the equation, we will get a square equals 5b square. We can take this as equation number 1. A square equals 5b square can be further written as b square equals a square by 5. Now, we will use the theorem that if p is a prime number and it divides a square, then p divides a, where a is an integer. Since 5 is a prime number and it divides the number of a form a square, it means that 5 must also divide a. So, we can write this as a equals 5c. 5 divides a is condition number 2. Now, squaring both sides of the equation a equals 5c, we get a square equals 25c square, which is equation number 3. Now, from 1 and 3, if we equate a square, then we will get 5b square equals 25c square. 5b square equals 25c square can be further written as b square equals 5c square. Again, we can write this as c square equals b square by 5. We will again use the theorem that if p is a prime and it divides a square, then p divides a, where a is an integer. So, since 5 is a prime number and it divides b square, where b is an integer, it means that 5 also divides b. We will take this as condition number 4. Now, if we consider the 4 conditions, from 2 and 4 we see that 5 divides a and 5 divides b, which means that a and b both have a common factor 5 and they are not co-prime numbers. But according to our assumption, we had taken root 5 as a rational number and a and b as co-prime numbers. Since a and b are not co-prime numbers, as we concluded from 2 and 4, we get a contradiction. Since we get a contradiction, it means that our assumption that root 5 is rational is a wrong assumption, and hence we can say that root 5 is an irrational number.